Hello and welcome to our demonstration on the work undertaken in the CHOREOS FP7 European project, addressing large-scale choreographies for the future Internet. In particular, we demonstrate discovery, access, and data fusion over large population of thing services. In the CHOREOS vision, service choreographies in the future Internet integrate both business services and thing services, thus leveraging the vast possibilities of things linking to the physical world via sensors and actuators. Specifically, a service interaction inside a choreography may take the form of a data query over a large population of thing services. As part of this setting, smartphones, which are getting increasingly ubiquitous and embedding a large collection of sensors, are currently being transformed into extremely powerful things. To enable this vision, the CHOREOS service-oriented middleware supports high-level programming of thing services on top of heterogeneous smartphone sensors, thing services discovery and access dealing with the large populations of network things, and on-the-fly composition of thing services and fusion of their data in response to queries over large things population. To see these features in action, let us check out the following scenario. Smartphone sensors can be used for many purposes. For example, the microphone allows capturing and measuring ambient sound levels at the user's location. For example, here are the noise levels from a crowded concert. This can give an approximate indication of how lively a place is. Making this data available in real time can help other users checking on a city map see how lively a spot of interest is, like a public garden, the pub's quarter, or a historical site. This may encourage or discourage them in choosing the spot where they want to spend their time in the next hour. The CHOREOS middleware allows sensor developers to easily write drivers for new types of phone sensors. For example, ambient sound level sensors using the phone's microphone, or wrap existing drivers, for example, location using the GPS sensor, and expose them to applications running on the phone in a uniform manner. In this way, a phone can further provide network access to ambient sound level data, such as a thing service exposing a RESTful interface. The CHOREOS middleware allows registration, lookup, and access to such thing services. Specifically, phones register themselves and their thing services with the things registry, which is accessible on the internet and potentially hosted by a cloud infrastructure. Among different metadata about themselves and their services, phones register their location. Consider, for example, the fact that in the city of Athens at any given time, there are a large number of active phones, each capable of reporting on the ambient sound level of its surroundings. If all phones registered, then a lookup in the registry would allow displaying their locations on the map of Athens. In our current implementation, we use a single real phone, indicated here with a special marker, and simulate sufficiently large number of populations of phones and their data. However, not all of these phones need to register. Not all the phones at the same spot need to report ambient sound level data. Some smartly distributed sampling should be sufficient. This enables efficient, scalable coverage of the entire city with only a subset of the large phone population being registered. The phone's thing registration manager includes a probabilistic decision algorithm for selective registration based on the truncated Levy-Walk mobility model. The registration decision is based on the actual density of already registered phones, the coverage quality requirements, and the coverage of the estimated path that the user will take for the next few minutes. So in the first case shown here, there is enough coverage along the user's path, which makes their phone more likely to not register. While in the second case, there is not enough coverage on the path, making the phone deciding to register. We demonstrate the effect of this algorithm for selective registration as displayed on the map of Athens. When we click on the Registered Devices button on this map, we can see that only some of the phones have actually registered, including the real device. When a user queries the liveness application, for example, the Acropolis archaeological site, by marking it with a rectangle, the request is processed by the Things Query Manager. The Query Manager retrieves from the registry the registered phones that are capable of reporting ambient sound levels inside the Acropolis site. The Query Manager then accesses the identified phones for their ambient sound data. Note that we have also developed a proxy mechanism that allows mobile phones to receive incoming requests in spite of being behind wireless service providers' firewalls. You can now see the ambient sound data reported by the accessed phones at the Acropolis site. These are displayed by the markers L, M, and H, which stand for low, medium, and high, and are yellow, orange, and red colored respectively. We will now show the live update of the ambient sound level reported by the real phone. For example, here you can see that the phone can accurately sense and report on the high levels of noise in the Acropolis. By averaging the ambient sound data from the registered phones at the Acropolis site, the Query Manager computes the on-site liveness level and can provide it to the user. The Acropolis liveness level is displayed by the user's phone, with yellow, orange, or red coloring on the map. Right now, the Acropolis seems to be pretty crowded. Concluding, we point out again our belief in CHOREOS that service choreographies in the future internet can leverage large populations of heterogeneous thing services and their data. This demonstration has helped to show our current results on high-level macro-programming support for heterogeneous things, scalable probabilistic registration dealing with large number of things, and finally, access to and fusion of the data. In our immediate next steps, we are eliciting high-level networking abstractions for heterogeneous things and targeting an overall scalable and efficient solution to discovery, composition, and data fusion for large thing populations. Thank you for your attention. For more information, you can check out the CHOREOS project website at www.choreos.eu.